In this video, we'll look at how to factor trinomials using the trial and error method. That's basically using the FOIL method for multiplication backwards. So we'll start with a quick review of that. Here are two binomials that we want to multiply. Remember that we take each of the terms from the first polynomial and we distribute them to the terms in the second polynomial. So we distribute the 5x by multiplying by the 3x and then multiplying by the 4. And then we distribute the negative 2, first multiplying by the 3x, and then multiplying by the 4. So these are all of the possible products that we get. And now we need to simplify this by combining like terms. We can combine the x terms, and this is the simplified product. These arrows are a good way to remember how to multiply polynomials with any number of terms. And when they're both binomials with two terms each, this process is sometimes called FOIL, because we have the product of the first terms, the product of the outer terms, the inner terms, and the last terms. And now we'll be working backwards. We'll start with the trinomial, and then we'll factor this by finding the two binomial factors, and we'll write it as this product. Here's an example where we want to factor the trinomial x squared plus 8x plus 12. So we need to find these two binomial factors, which means we need to find the two terms in each factor, so that the product, when we multiply these using FOIL, will equal the trinomial that we started with. We'll begin with the leading term x squared. That can be factored as x times x, and those factors must go in the first positions of the two binomials. Then we look at the factors of the last term in the trinomial, 12, and these factors will have to go in the second positions in the binomials. There are three different ways we can factor 12, either 3 times 4, 2 times 6, or 1 times 12. And because these factors have a product of positive 12, each pair of factors will either be both positive or both negative. Both factors must have the same signs if their product is positive. There's a shortcut we can use here. Since the middle term in this example is positive, that'll tell us that these factors must both be positive and not negative. So now we want to try plugging these factors into the four positions in our binomials to see if we can find a combination that works. As we said before, the factors from the first term have to go in the first positions in these binomials, and in this example we only have one choice, x and x. The factors of the last term go in the second positions in these binomials, and this time we have three choices. Let's start with the factors 3 and 4. So here's the plus 3 and the plus 4, and now we'll check this. The product of the first terms gives us x squared, the product of the outer terms gives us 4x, the product of the inner terms gives us 3x, and the product of the last terms gives us 12. And now we simplify by combining like terms, and that gives us x squared plus 7x plus 12. Notice that the 7x in our middle term is not the same as the 8x in our trinomial, so this combination of factors does not work, and we'll have to try a different one. Before we do that, let's simplify this process to make it easier to check our combination of factors and find one that works. Notice that the product of the first terms will always give us the first term in the trinomial, because we're using its factors, so we don't really need to check this part. So we can remove that arrow and the corresponding product when we check our two binomials. And the second terms, or the last terms in these binomials, are factors of 12, the last term in our trinomial. So this product will always equal 12, and we don't need to check that one either. That means that we really only need to check two products, the product of the outer terms and the product of the inner terms, to see if we get the correct middle term in our trinomial. I'm going to move this top arc down below, and then move each of these products underneath their corresponding arc. And this is all we'll have to check to see if a given combination works for our given trinomial. And as we said, this one does not work because we do not get the correct middle term. Before we move on to the next pair of factors, we should really check to see if the order that we put the first pair of factors, the 3 and the 4, makes a difference. So here we have the opposite order with the 4 in the first binomial and the 3 in the second. If you check the inner product and the outer product, you can see that we still have 7x. And that's because in this example, the factors that we have in the first positions are the same. So we get the same two products in either order. So this combination does not work, and we can move on and try another pair of factors. So again, we'll use the factors from the first term, x and x, to go in the first positions of our binomials. And now we'll use the factors 2 and 6 from the last term to go in the second positions. And now we can check the inner product, 2 times x, and the outer product, 6 times x, and you can see that these do add up to 8x. So this combination works, and we have correctly factored this trinomial. Once we've found a combination that works, we're done, and we don't need to check any others. But for this first example, let me show you a complete list of all the combinations so we can see the pattern. Here are all the combinations of factors that we can use to form the binomials in this example. We didn't check the factors 1 and 12 because we already had a combination that worked. But we can take a look at that here. The product of the inner terms gives us 12x, and the product of the outer terms gives us x. And this adds up to 13x for the middle term. So this combination would not have worked either. You can also see from this list that in this example, it doesn't matter what order we put the second terms in, because when the first terms are the same, we get the same two products, just in the opposite order. So we get the same middle term. We'll see that the order does matter when the factors in both pairs are different. You can also see from this that the order of the two binomial factors doesn't matter. We have the answer x plus 2x plus 6, but x plus 6 times x plus 2 would also work. Either of these would be fine for your answer. The last thing to note here is that in each of these combinations, the first term is always x squared, and the last term is always 12. So the only thing we really need to check here is the middle term in each of these combinations. And we do that by looking at these two products. Remember here we only checked the positive factors of 12. Because 12 is positive, that means that both factors have to have the same signs, either both positive or both negative. We chose positive factors because the middle term in our trinomial was positive. And you can see in each of these combinations that we got a positive middle term. Just to compare what would happen if we'd used both negative factors, for example, -3 and -4, the inner product and the outer product would both be negative, and that would give us a -7x in our middle term. It's easy to verify that the other combinations also give us a negative middle term. So the only difference when we use two negative factors instead of two positive factors is that the middle term is negative. So in the trinomial, the middle term will tell you whether they're both positive or both negative. You might ask, what happens if we don't get any combinations that give us the right middle term? Well, in that case, assuming that we didn't miss any of the possible combinations, the trinomial would not be factorable. I want to look at one more example. Again, we're trying to factor this trinomial into a product of two binomials. And our first step will be to find the factors of the first or leading term. 4y squared can factor as 2y times 2y, but in this example, we get another possibility, 4y times 1y. You can see we always split up the variable, but we have to look for different factors of this coefficient. Another difference in this example is that the last term is negative. 15 has factors 3 and 5, and 1 and 15. But because this is a -15, these factors will have to have opposite signs, one positive and one negative. And now we'll look at different combinations of these factors in our two binomials. Again, we'll start with the factors of the leading term. These will go in the first positions of our binomials. This time we have a choice. Let's go ahead and start with the 2y and the 2y. And now for the 15, let's use the factors 3 and 5. These will go in the second or the last positions of our binomials. This time the factors are going to have opposite signs, one positive and one negative. And right now we don't know which one will be positive and which one will be negative. I actually prefer to leave them blank for the moment and look at the product of the inner terms and the product of the outer terms and note that they will have opposite signs, one positive, one negative. And that means that this time we'll have two possibilities for the middle term, either negative 4y or positive 4y, depending on which of the products is positive and which one is negative. And that's enough for us to tell that this combination won't work, because we can't get the positive 7y that we need for the middle term. Since the first terms here, 2y and 2y, are the same, switching the order on the 3 and the 5 will not make a difference. We'll get the same possible middle terms. That means that the 3 and the 5 will not work with the 2y and the 2y. So now we need to try 1 and 15. So we're sticking with the 2y and the 2y in the first positions, and now we'll use the 1 and the 15 in the second or the last positions. And remember, these will have opposite signs. One will be positive and one will be negative. And that means that the product of the inner terms and the product of the outer terms will also have opposite signs, one positive, one negative. Therefore, we either get negative 28y or positive 28y for the middle term. Neither of those is the positive 7y that we need for the middle term in our trinomial. And again, changing the order on the 1 and the 15 will not make a difference when the first two factors are the same. And that means that none of the factors for 15 work with the factors 2y and 2y. So now we need to try the other pair of factors, 4y and 1y. For the factors of 15, let's start with the 3 and the 5. Again, we'll have one positive and one negative. So we have the product of the inner terms and the product of the outer terms with opposite signs. And that means we either get a positive or a negative 17y for the middle term with this combination. Neither of those gives us the positive 7y that we need. But we're not done with the factors 3 and 5. If we change the order, we'll get something different because the first factors are not the same. Let's see what that looks like. So changing the order on these factors, we'll put the 5 first and then the 3. These will have opposite signs. So the product of the inner terms and the product of the outer terms will also have opposite signs, and that means we can either get negative 7y or positive 7y for the middle term, depending on which one's positive, which one's negative. And we want a positive 7y, so we have a combination that can work here. We just need to figure out where to put the positive and where to put the negative, and we can work backwards from here. To get a positive 7y, we'll need to combine a positive 12y and a negative 5y. And working backwards from our products, if the 12y is positive, that means the product of the outer terms is positive, so we need a positive 3. And to get a negative 5y from the product of the inner terms, we'll need the 5 in the first binomial to be negative. So now we have a combination that works, and we've factored this trinomial as a product of binomial factors. And once we found a combination that works, we don't need to check any others. After some practice, these steps aren't too difficult to follow. Remember that the factors of the first term in the trinomial go in the first positions of the binomials, and the factors of the last term of the trinomial go in the second or last positions of the binomials. And then we check the different combinations of these factors in our binomials to see which one gives us a product equal to the given trinomial. And the shortcut is to check the products of the inner terms and the outer terms to see which ones combine to give us the correct middle term. With practice, you'll get better at picking which combinations are most likely to work, so you won't have to check as many. You can really check the products of the different pairs up here and see which ones are most likely to give you the right middle term. But if necessary, you can try the different combinations systematically until you find a product of two binomials that works, or if none of them work, then the trinomial is not factorable.